This is lesson 15-6, Understanding Inequalities. Our essential question, how can you solve an inequality? And this picture shows a good example of inequalities on a number line and how we're going to write those. There's no vocab for this lesson. Example number 1, write the inequality that the graph represents. Okay, so we can see on this number line that the circle is on the 14. So it's going to be something to do with 14. Then your next thing you need to look at is which way the arrow is pointing. In this case, it's going this way, which is going toward the smaller numbers. You can see it started at 14 and then it's going 13, 12, 11, 10. So we know that it's going to be less than. So we are having a less than problem. And if they don't give you a variable, let's just use the variable x. So we're just saying, looking at this, that x is less than 14 because it's going to be going toward these smaller numbers. So it could be any of these numbers that are smaller than 14. Now it's less than because it has an open circle. If the circle was closed, it would be less than or equal to. Example 2, name 3 solutions that make this inequality true. So x is greater than 5. So we're trying to figure out 3 numbers that could be x. What are 3 numbers that are greater than 5? Well, there's lots of choices. We could do 6, 7, 8, 10, 20, 30. There's a lot of numbers that are greater than 5. So that's what our x values could equal. Those would be 3 solutions that make this true. If we put any of those numbers in place of the x, it would be true. Example 3. So we see that the dot is on the 2. And we can see it's a closed dot. So we know it's going to be also equal to. Remember, if it's closed, it's also equal to. Now, this time it's going toward the right. It's going to the bigger numbers, 3, 4, 5, 6. So it's going to be greater than or equal to. That's how we write that. We put the greater than sign, and then we just put a line underneath of it to show that it's also equal to. So if the circle is closed, you're going to have a line underneath your symbol. And again, we'll just put x for our variable. So x is greater than or equal to 2. So if we put in a number for x, like we did in the last example, it would have to be something that's greater than 2 or equal to 2. Example number 4, name 3 solutions that make the inequality true. Now this, x over 4, is a fraction, which means it's also a division problem. X divided by 4. So we have to think what numbers for x, when they are divided by 4, are going to be less than or equal to. I know it's or equal to because of this little line underneath. 60. Well, I know if I put in, let's try something. Let's try 12. 12 divided by 4 is 3. And 3 is less than 60, so that must work. So 12 can be an answer. Let's also try 40. 40 divided by 4 equals 10. and 10 is less than 60. So 40 can be an answer. And then how about the last one? 48 divided by 4 is 12, which is also less than 60. So 48 can be an answer. So 3 solutions for x could be 12, 40, and 48. So that means I could put them right here for the x, and this would be true. So 12, 40, and 48 can all be divided by 4 and be less than 60. Here are your 4 practice problems. Don't forget a word problem or a question, and rate your understanding.